In this first video, we're going to look at this function, f of x equals x minus 3x to the 2/3. And we're going to look at intervals of increasing and decreasing and trying to find local extrema. Okay, so first thing we have to do is find the first derivative. So here, it's just a simple power rule. That 2/3 is going to come down with a 3, so I'll have 2x to the negative 1/3. Okay, to find critical numbers, we always set it equal to 0 and solve. A lot of students, when they get fractional exponents, they say, what should I do? Okay, number one, what you should do is turn it back into a root. So here, this would be the cube root in the denominator. Okay, sorry, my board has a mark right there. Okay. All right, beautiful. And the next thing that happens is that students try to just solve this by moving it to the other side and all the good stuff. If you have a denominator, you need to make a common denominator, because if you just start isolating the x, you will lose solutions. I'm going to say that one more time. If you just try solving this for x right now without making a common denominator, you will lose solutions. So the only safe way to do it is we're going to multiply this guy by a cube root of x minus 2 over the cube root of x. All right. All right, now what we're going to do is, now that we have it in a fraction, we're going to set the top equal to 0. And we're going to set the bottom equal to 0. Okay, the bottom, we're going to get the critical point of 0, which we would have lost if we didn't make a common denominator. And then over here, I'm going to get the cube root of x equals 2. When I cube both sides, I'm going to get x is 8. All right, so those are my critical points. My critical points are x equals 8 and x equals 0. All right, it's number line time. All right, there we have it. So what I'm going to do is I'm going to plug into this version of the derivative. So I'm going to plug in negative 1, 1, and 9. So let's see what we get. So if I plug in negative 1, the cube root of negative 1 is negative 1, minus 2 is a negative. On the bottom, the cube root of negative 1 is also a negative. So a negative divided by a negative is positive. Okay, then I'm going to plug in 1. So when I plug in 1, the cube root of 1 is 1, minus 2 is a negative value. The cube root of 1 is positive. Okay, so I've got a negative over a positive. That's a negative. All right, now I said I was going to plug in 9. I actually want to plug in 27. And you're going to think, Jen, why did you choose 27? Because it's a perfect cube. So I think it'll be easier to plug in down here. So the cube root of 27 is 3. 3 minus 2 is a positive. The cube root of 27 is also 3, which is positive. So positive over positive, positive. Okay, here we go. We can now say that f is, sorry, I'm making room. F is increasing, decreasing, and then increasing. So if I go up and then down, this is a max. If I go down and then up, this is a min. So I've got f is increasing from negative infinity to 0, and again from 8 to infinity. It is decreasing from 0 to 8. I've got a local max at 0, and I've got a local min at 8. Okay, y value time. To get your y value, you need to go back to the original function. So if I plug in 0, I'm going to get 0. If I plug in 8, I'm going to get 8 minus 3 times the cube root of 8, which is 2 squared. So I think I'm going to get negative 4. All right, double check my work. So I did the cube root of 8 is 2, 2 squared is 4 times 3. I think we're going to get negative 4. All right, so there's my intervals of increasing and decreasing, local max and local min. In the next video, we will do concavity.